Hello, this is William from Visual Components. In this video, I'm going to show you how to read a robot program using our Python API. This will require access to the Modeling tab, but you can use a Python add-on or a .NET API add-on to complete this tutorial. To get started, in the 3D world I have a layout open, which you can find a link to in the video description. So load that layout in the 3D world. There's a robot, a cube, and a palette. Let's now go to the Program tab and use the jog command to select the robot in the 3D world. In the Program Editor panel, we can see the program of the selected robot. So it has a main routine and 4 subroutines. So what we're going to do, we're going to create a Python script in the robot to read all of this data. So if I actually start the simulation for you, you can see what happens. The robot picks up a cube, places it on a pallet, picks the cube from the pallet, and puts it back on the floor. And there is a loop in the robot program, so it's going to do the same thing a couple times. And then eventually it exits out that loop, and the robot is done, and the simulation stops. Now, one thing to mention is that we're not going to get into pass statements in this video. That's going to be covered in another video. So let's reset our simulation and go to our Modeling tab. And I have the root node of the component selected. I'll go to the behavior group, click the behaviors arrow. And under miscellaneous, I'm going to click Python script to add that behavior to the component. And this also opens the editor for me. Now we don't need these lines of code here. And let's start by getting a handle for the component of this script. So we'll say comp equals get component. And whenever you want to read a robot program, you have to get a handle for the executor of that program. And an executor is a type of behavior in a component. So we'll say robot executor equals, and we'll use the component object to find a behavior. If you know the name of the executor, you can use this method. But if you don't, you can say find behaviors by type. And this will return a list of all the behaviors of the given type in the component. So we'll search through all of its nodes to find the behaviors. And the type you're looking for is called R robot executor. And this will give you a list, so we just want the first executor that's found. Let's print that out. I'll compile the code. And in the output panel, we can see that our robot executor is a VC executor object. So now that we have a handle for the executor, we can now access its program. So we'll say robot program equals robot executor, and this is going to be a property of the executor called program. So let's print that out. Compile the code. And in the output panel, notice that a robot program is a VC program object. So if we go back to the Program tab and look at the robot's program, we can see there are a main routine and 4 subroutines. So let's get access to those routines now. I'll clear out my print statement here. And let's first get a handle for the main routine in the robot program. So main routine equals robot program, and this is going to be a property called main routine. Let's print that out and compile the code. And in the output panel, notice that every routine in a robot program is a VC routine object. So if we now get a handle for the subroutines, let's say subroutines equals, we're using our robot program object. And this time the property is called routines. So this will give you a list of all the subroutines in that program. Let's print that out and compile the code. Notice in the output panel there's 1, 2, 3, 4 subroutines in the robot program. And if we go to the Program Editor panel, that does match up. And notice that that list does not include the main routine in the robot program. Now in some cases, a routine in a robot can have variables. So if I select the main routine here in the Program Editor panel and go to the Routine Properties panel, notice that it has one variable called count. So if you want to access those variables, it's very easy. Let's go back to our script and say for property in main routine dot properties. So this is a list of properties in the main routine. Let's print out their names. So print property dot name. Let's compile the code, and we can see in the output panel we have the name property and that count variable. So you can do that for any routine in the robots program. So just get the properties to get handles for the variables. Let's now get handles for the statements in a routine. So we'll say statements equals main routine, and you just have to use a property called statements. So this will give you a list of the statements that are in our routine. So if we print this and compile the code, notice in the output panel something very interesting. So we have only two statements in the main routine. But if we go to the program editor panel, we can see that there are more than two statements. We have 1, 2, 3, 4, 5, 6, 7 statements. The reason why this happened is because that every routine in a robot program has a scope. The main routine scope are these statements. The scope of this subroutine here are these statements. But if we go back to the main routine, notice that a statement can also have its own scope. So this while loop here, this while statement has this scope of statements. Now a routine inherits an object called VCScope, and that's why you can refer to it as statements using this property here. So if we now check if a statement has its own scope, let's see what happens. So I'll say for statement in statements, if the statement has a list called scopes, so we know that this while statement has at least one scope, these statements here. Let's print that out. So let's say print statement.scopes. Compile the code, and we can see in the output panel it returns a list of the scopes, and the while statement has one scope here. So now let's see what happens when we do another loop called for scope in statement.scopes. Let's print out the statements of that scope. So notice here, the routine in a robots program, you can reference this statements property because it has a scope, and a statement can also have one or more scopes, and you refer to the statements that are in that scope or nested in it. So if I compile the code, we can see we get a much longer list here, so it's returning the statements that are in our while loop. So to get all the statements in a routine, let's create a method. I'll say define get all statements in routine. Instead of giving a routine object, let's just give a scope object. So I'll say my first argument, or first parameter, is called scope, and we want to collect all those statements in a list. So my second parameter will be an optional one called statements, and we'll set it equal to none. And what we'll do at the start of the method is to see if that statements argument is none or it doesn't contain anything. So if statements equals none, we'll then create a new list. So statements equals an empty list. Now another way to write this is to say if not statements. So if we don't pass any argument here, it will still check this and create a new statements list. And then let's loop through the statements in our scope. So it can be a routine or it can be a statement with a scope. For statement in scope.statements, we'll append them to our list. So statements.append statement. And now we're going to check if that statement has a scope or one or more. So if statement.scopes, let's create another loop. So for scope in statement.scopes, what do we need to do here? Well, we don't want to write the same thing over and over again. So let's use recursion to call this method again, but this time we're passing it the scope of a statement and that statements list we created. So I'll say get all statements in routine. The first one will be the scope and our statements list. So it's not going to create a new empty list. It'll just use the existing one we passed to the method. And then after we exit out of our statements, we get everything. Let's return our statements list and see how this works. So let's print the length of the list that's returned with our method. So I'll use a built-in function called length. Get all statements in routine. And we need to give it our main routine first. And we're not giving it a second argument, so it will create an empty list for us. So let's clear the output panel. And I think I didn't make any mistakes, so let's compile the code. And it seems I did. So I forgot to add a colon here. Sorry. Let's compile the code again. And in the output panel, we can see we get a count of 7. So we know there are 7 statements in our main routine. Let's see how this works with our subroutine. So let's say robot. Let's actually use our list here of subroutines. So subroutines. And let's use that first as subroutine. So I'll use an index here of 0. So if I compile the code, in the output panel we get 4. So if I go to any of these subroutines, you can see it does have 4 statements. So this one has 4, this one has 4, and so do the other ones. Let's go back to our main routine, and let's actually get all the statements in the robot program using this as an example. So instead of printing that out, let's define a new method called getAllStatements in program. And that might be a bit confusing, so let's say getAllStatements in robot program. And what can we do here? Well, let's actually take a program as the argument, and we'll call our method we used for getting the statements in a routine. So we'll say statements equals get all statements in routine, and we'll pass it the program.mainRoutine, and that will be what we return. And let's see how this works. You probably already have some alarms going off in your head what can happen. So let's say print get all statements in robot program, and let's give it our robot program we found earlier. So if we clear our output panel and compile the code, we can see we get quite a long list in the output panel, but let's print the length of that. So it should probably be more than 7. That's what we're expecting. So we use that built-in function again of length. Compile the code, and we get 7. Now we know that's not true. The main routine has 7 statements, but notice we're calling these subroutines, which have 4 statements each. So to fix that, we don't have to make any changes to this method here to get all the statements in a robot program, but we can alter this method here to get the statements in a routine. So what we can do, let's add another condition here. And I'm first going to go back to the main routine and show you what I'm talking about. So if I select one of these call sequence statements, in the statement properties panel it has a routine property. So we can check if a statement has this property and then call that method we created to get the statements of this routine. So we'll say subroutine equals statement.getProperty routine. Now if the statement doesn't have that property, this is going to give me a null value. So if subroutine, if there is a value, what do you think we're going to do? Hopefully you guessed it, we're going to call the method again. So get all statements in routine, and then we'll pass that subroutine. But we don't want to pass a VC property object, we want to pass a object that has some type of scope. So in this case we're going to use the value of that property, so it'll give us the routine or the subroutine. And we want to use the same list, so I'll pass it also our statements list. And let's see what happens. So if I compile the code, now look what happens. Instead of 7, we get 23. So there's 7 in the main routine, and each of these subroutines has 4 statements. So 4, 8, 12, 16 plus 7, that's 23. Now for our method get all statements in routine, we probably shouldn't have this here. We should probably put it for getting the statements in the robot program, because technically the statements in these subroutines are not in the routine we're calling this method with. So let's actually take this code and cut it and go to our other method here, and we'll say for statement in statements, and then we'll paste in our code. And what we're doing here, let's just fix the indentation, that if that statement has a routine property, we're then going to call our get all statements in routine method with the value of that property and our statements list. So let's see if that still works. I'll compile the code, and we still get 23. Great. Let's now see how this works when a statement has more than one scope. So if we go to the Program Editor panel, our while statement has one scope, but let's now add an if statement. And we don't want that to be inside our loops, so I'll drag that to be above the while statement, and then move our while statement above that. And for our if statement, let's define a condition. So in the Statement Properties panel, I'll say if the count is equal to 2, then we can do the statements in this scope here, else we do the statements in this scope here. So the if statement, it has a then scope and an else scope, so a total of 2. So if the count is equal to 2, then we'll print something. So add a print statement and give it a message of robot picked and placed a cube. Else, let's just add a comment here. So I'll add a comment statement. And notice what happened here. I added one statement that has 2 scopes, and each scope has one statement each. That's a total of 1, 2, 3. So now the count of statements in our robot program is not 23, it should be 26, and the count in our main routine should be 10. So let's see how this works. Let's go back to our script. And before we print the length of all statements in the robot program, let's print the length of get all statements in routine. In this case, we're passing the main routine. So notice the difference here. This method will give us the length, will get us the statements in our main routine, or just any routine we pass it, and we're returning the length of that. We're then getting the length of all the statements in the robot program, so how many there are. Let's compile the code, and we get some interesting results. So now we have 10 statements in the main routine, and 26 in total in the robot program. So I hope by now you're more comfortable with using the scope of a routine and the scope of a statement. So that's why I took my time here creating these methods for you and explaining how they worked. Let's now get handles for the positions in our statements. So if a statement is a motion statement, it contains a motion and a point, let's get handles for those positions. So I'll say positions equals an empty list. And if we see in our main routine, it doesn't have any motion statements at all, so we probably don't want to use that. Let's use one of these subroutines here. So let's say for statement in subroutines dot statement statements. Say we want to know if the statement has what's called a positions property. So if it has any positions, the robot has to move tool. So we'll say, let's actually print the statement itself. So print statement. Let's compile the code. And list object has no attribute statements. Interesting. I made a mistake here. Let's get the first subroutine in the robot program. So I'll use an index value of 0, and then use that statements property. Sorry. Let's clear our output panel and compile the code. And here we go. It's probably this first subroutine here, this pick cube from floor. We can see it has 3 motion statements and that set binary output statement. So in the output panel, we can see we have 1 motion statement, 2 a regular statement, and another motion statement. Great. So a motion statement in a robot's program is of this object, so VC motion statement. Now, this VC motion statement, it inherits a class called VC position statement. So we can know if this motion has any positions by referencing this property here called positions. Now, not every statement is going to have this attribute, so in order to try to print out the positions, let's use a try catch statement. So try print statement dot positions, and of course you'll probably figure it out. This is returning a list of positions in that statement. But if there's an exception, let's just continue in the loop. So what we expect to happen is that if the statement has this property called positions, or this attribute, it will print out a list of its positions, except it will just continue and loop back in the loop. So let's compile the code, and we can see that we have what's called a VC position frame. So this is the object for a position of a motion statement. And a VC position object or a position can be referenced by more than one motion statement. So I'm sorry, it's a VC position frame for our approach and retract position. They're using the same position basically. So let's actually clear our output panel and try to get a list of all positions in our robot program. So let's first start small and define a method to get the positions in a routine. So get all positions in routine. And let's give we just need to give the routine or the scope. And then we'll call our method to get the statements in that routine. So get all statements in routine and pass it that scope argument. And then we'll create an empty list called positions equals, and for statement in statements we'll try if the statement has this positions attribute. If statement dot positions, we'll add those positions to our list. So positions dot append statement dot. Actually, let's loop through that. We actually don't need this if statement. So for position in statement dot positions, let's append that position to our list. So positions dot append position. And of course, if there's nothing there, let's do the accept and let's just pass. Then what do we want to return? We want to return our positions list. So let's see how this works. And I'll create some white space. Let's print out get all positions in routine, and let's give it the main routine of the robot program. And this probably should be empty. And in the output panel, yep, it's an empty list. But for the subroutines, that's different. So let's say for subroutine and subroutines in a robot program, we'll call that method. So print get all positions in routine, and we're giving it the subroutine in the robot program. So let's see how that works. Compile the code. And if we look at the output panel, notice that every subroutine has the same amount of VC position frame objects, or the same amount of motion statements. So this pick cube from floor has 3 motion statements, and the same for the other subroutines. And the reason why we have 3 VC position frame objects as opposed to the 2 we saw earlier is because for my accept here I just used a pass keyword. And depending on the statement type, a VC position frame object, might have some different properties for a point-to-point motion statement as opposed to a linear motion statement. So now that we have a method for getting all the positions in a routine, let's get all the positions in the robot program. And this time, let's give a program as the argument. And we'll basically be calling our get all positions in routine first. So positions equals get all. Let's first get a list of statements in the robot program. So we're going to use our get all statements in robot program. Because you can see here, I use the get all statements in routine, but now I'm going to use the get all statements in robot program. Got a little too excited. And we're going to pass that robot program. Create some white space. And then create a list of positions. And then for statement in statements, we'll do the same thing we did again here. But that might be a bit repetitive, so let's actually change our loop here to do what we did here for the subroutines. So let's copy and actually cut this code here and then paste it into our method. And we're not going to print that out, so let's get rid of that. And then for the subroutine in our subroutines in the program, let's make sure we have a handle for that. So we don't need this statements list right now. We actually don't need it at all. So positions is an empty list, and for subroutine in program dot subroutines, or actually sorry, routines, and we should probably call our main routine first. So let's say positions equals get all positions in routine program dot main routine, and then we'll go and call each subroutine in the program. So for subroutine in program dot routines, let's say positions, and at this point it's kind of how do you want your list to look like. So let's say positions in routine equals get all positions in routine, and we'll pass that subroutine, and this will give us a list of positions in this routine, and what we're going to do now is merge that with this list here. So I'll say for positions in, let's make this subroutine actually. And we need to rename that variable here as well. So for the position in that list we get from the subroutine, let's append it to our list in our method. So positions.append position. So far so good. And then let's create some space here. Let's return that positions list. And let's check by printing out the length of that positions list we create in our method. So print len get all positions in robot program, and we'll pass it our robot program we've been working with. So what do we expect to happen? We know that each subroutine has 1, 2, 3 positions. So 4 times 3, we probably expect a count of 12. So compile the code, and at the output panel, yep, we get 12. So we did a lot in this video, but I think we're not done yet. Let's take a look at all our work. So we have, at the start, we first got a handle for the component. We then got a handle for an executor in the component, and that executor allowed us to access its program. And then from the program, we were able to access the main routine of that program and its subroutines. We then got a list of statements in the main routine, but we noticed that it did not include any statement that had a scope, so we created a method to get all the statements in a routine by taking the scope of a statement into account and returning a list. We then created a method to get all the statements in a robot program by making sure that we loop through all the statements that called a subroutine and then returned a list. We then got all the positions in a routine, so any type of motion statement, we return that as a list, and then we got all the positions in a robot program. So what we can do, this is some good work I hope that you like, we can copy these methods and put them into a Python file which we can then import for later use. So what I recommend you do now is open a note editor. In this case I'm going to open Notepad++, and let's copy our methods. So I'll start from the bottom. Now we're up, and let's copy all these statements. Right click and copy them. Let's now go back to our Notepad editor and paste them in. And that looks fine. And let's now save this as a Python file. So I'll first go to the language menu and make sure this is set to Python. It doesn't look like there's any errors. Let's now save the file. And you want to save it in a specific location, so you can go to the libraries, your documents library, go to your Visual Components documents for your 4.0 product, and go to this folder here called My Commands. So save the file in this directory for, it's easy to find, it's easy to edit, and you can import it easily with the software. So I'm going to save this as a Python file, and let's call it, what's a good name? Pizza Party? No, probably Robot. Probably Read Robot Program. But you can call it whatever you want. So I'll save that. And that's done. So let's close out our notepad. And now, instead of having all these methods, let's actually delete them from our script. You're probably saying, no! But we still have a handle for the robot executor, the program, the main routine, and the subroutines. But now we're going to import that file. So from read robot program, we're going to import everything. And now let's try one of those methods. So let's print get all statements in routine, and let's pass the main routine as an argument. Let's clear our output panel, compile the code, and we got a list of statements, y'all. All right, let's get the length of that to make sure. So use that length method again, compile the code, and we get a count of 10. And if we go back to our main routine, yep, there are 10 statements. So now you have a helpful module that you can import to read a robot program. And if we actually go back to that module, if I go to my documents real quick, and go to my commands folder, we can see that that Python file we created, the Python, when it compiled it, automatically created this PYC file. Now you can keep this, it does make compiling a bit faster, but you really don't need it if you don't want to and you don't want to have extra space in your My Commands folder. So if I delete this, it's not a problem, the code will still work. So if I now use a different method, let's say get all statements in robot program, and pass it that robot program we have in our script, and compile the code, you can see that it still works. We have an output of 26 statements, which is the total of statements in this program. Alright, this concludes the video. It was a bit long, so feel free to go back and watch the video, but hopefully at the end you have a helpful module for reading a robot program, and you understand how a robot program is structured in Python API. Now, if you have any questions, you can go to our forum at forum.visualcomponents.com, and as always, I hope you have a wonderful day.